Topic 6, Polynomials, the remainder theorem. In this lesson, we will be learning about how to know and use the remainder theorem. Key terms and concepts. Polynomial function. When it's in its expanded form, it looks like this, and when it's in summation notation, it looks like this. X can be any variable. R, not shown here, but R can be any one of the powers of x from 0 to n, where n is the highest exponent of n. And a is the coefficient of x, unless it's a n, in which case it does not have an x value because x will be to the power of 0. Summation notation is the same, where n and r are all the same, as shown in the polynomial function. Real polynomial, it's given as px, a polynomial for which a, r is included in the set of real numbers. It's shown as this. And that is all numbers except for imaginary numbers. For example, square root of -1, which gives you an error message, and infinity, which cannot really be given a numerical value. It's represented as r is from 0, 1, 2 to the highest exponent. Polynomial function, the highest exponent of x in any kind of polynomial function is given to be the degree. So here it's x to the 1, so that's the degree. Here it's x to the 4, so it's 4. And they've all got specific names. Here we'll just be working with linear and quadratic functions. So addition, polynomials basically just act like normal numbers. You've got px, x cubed minus 2x squared, add 3x minus 5, and qx, 2x cubed, add x squared minus 11. So if they're added together, you collect the like terms, so x cubed, x squared, x. There's no x here, so we just put in a 0x, because 0 times whatever number is going to be in there, in that x, will of course be 0. And then you've got minus 5 minus, add 11. So you add them all together, and then you add the answers together to get 3x cubed minus x squared, add 3x minus 16. Subtraction is the same, collecting like terms. Same question as before, except now you're minusing px minus qx. Same thing, but now you're subtracting again. Be careful, you've still got that 0x, but here, instead of having a add minus, you've got a minus minus to get a plus. So in the end, you get minus x cubed minus 3x squared, add 3x, add 6. Scalar multiplication, you've got to multiply each term in the polynomial by the scalar. They're usually represented like this, with a number and then the polynomial representation, px. So 3px is equal to 3 times the entire polynomial in brackets to get 3x to the power of 4 minus 6x cubed, add 12x, add 21. Pretty simple. Complex multiplication, they act the same. Px times qx. Multiply them both together, but they're both in brackets. You can do a grid, you can do whatever kind of method of multiplication you'd like. Just be careful, because remember, you've still got to add up those kind of squared and x to the 1s and etc. So you get 2x to the power of 5, add 3x to the power of 4, minus 9x to the power of 3, add 2x to the power of 2, add 22x, add 20, minus 20. The remainder theorem. So you can have like a simple, so it's generally represented algebraically by the polynomial px divided by x add b is equal to qx add r over ax add b. They've got specific names, so the divisor here, the thing that you're dividing the polynomial by, is called is ax add b. The quotient, the bit of the polynomial that can be divided cleanly by ax add b, is qx. And the remainder, which can't be divided cleanly and so remains as a fraction, is r. So here, 2x squared, add 3x, add 4, times x, add 2. This thing acts as an entire polynomial, as an entire number by itself. And then you've got an add 7 at the end. So it can also be represented as this. It's being divided by x add 2. So then you split it down this way to get 2x squared, add 3x, add 4, times x, add 2, all over x, add 2, add 7, all over x, add 2. Cancel this out. So this bit is the quotient. 2x squared, add 3x, add 4, so it's quotient. The divisor is x, add 2. And because 7 can't be divided by x add 2, the remainder is 7. So here you've got to use the long division process. So unfortunately this is a bit of a lie. So x4 add 4x cubed minus x add 1, x squared minus x add 1. So here you've got 4, 3, 1, 0. So between the 3 and the 2 powers, you inject an add 0x squared. Again, as previously mentioned, when you times x to the power of 2, when you times an x value by 0, it comes out to be 0, but we still need to do this because in long division, you need to have something for every single power that has been kind of explained here. So what you're trying to do in long division is you're trying to get that first kind of number that you've got in your divisor to be equal to the first number that you've got in your in the thing that you're trying to divide. So here you've got x4. You need to make x squared into x4. You multiply by x squared to get x4. And then the rest of it gets multiplied by x squared as well. You multiply the entire thing off. So x4, 4x cubed minus x cubed. Add 0x squared, add x squared, minus. Then you continue doing that, bringing the next number in the original polynomial down to each kind of answer that you've got, until you finally reach either 0 or this thing here, which is the remainder. You multiply each thing by individual stuff. So then the quotient here is the numbers that you would be multiplying by. So you got x squared, add 5x, add 4. That's the quotient. The number that you were left with is the remainder. So that's minus 2x minus 3. And the number you're dividing by, x squared minus x, add 1, is the divisor. This is represented algebraically by px divided by x squared add bx add c is equal to qx add ex add f over ax squared add bx add c, where qx is the quotient, ex add f is the remainder, and ax squared add bx add c is the divisor. We will now go on to some questions. But before that, we will so the remainder theorem is commonly written as px divided by ax add b is equal to qx add r over ax add b. However, it can be written differently. So you can have px is equal to x minus k qx add r. And this x minus k, when you divide px, so when you divide px by x minus k, it leaves a constant remainder r. And when you put k into the x value, pk is equal to r. So here's the question.